Hello there, this is the Maths Tutor Online. I hope that I find you well. Today we're going to be talking about electrostatics and gravitation. This will just be a short introduction on Coulomb's law and Newton's law of gravitation. From your earlier studies, I'm sure you know what induction is. Okay. And induction usually takes place when you bring a charged object, okay, to another, close to another charged body. So what happens is like charges repel, okay. If you look at diagram A here, the charges are in balance, equilibrium, okay. But when we bring a negatively charged object, okay, it pushes the negative charges away, okay. And when we do that, you can earth away all the negative charge to ground, okay. So let's quickly talk about what induction is, okay. So for example, if you have a charged balloon, okay, and we bring it closer to a wall, okay, it induces the opposite charge closer to it, okay, and it pushes the positive charge away from it, okay. Like charges repel and unlike charges attract. If you look at diagram A, the charged object on the left induces a charge distribution on the surface of an insulator due to realignment of charges in the molecules. And in the second diagram, I'm sure most of you are popular with this little experiment. A charged comb attracts bits of paper because charged molecules in the paper are realigned, okay. So it's a principle of induction and charging and electrostatics that makes you be able to pick up pieces of paper with a comb that you rubbed against your hair. Okay, so let's quickly talk about Coulomb's law. But before we talk about Coulomb's law, we can talk about induction. It's got several uses in automobiles, electric cars. Okay, if you're going to be an automobile electrician or an automobile technician, okay, it will be very important for you to understand how charges move in conductors, semiconductors, and in insulators. Okay, now let's quickly talk about Coulomb's law. This law came into effect from a gentleman called Coulomb. Okay, he did this experiment using what's called a torsion balance, and he used it to establish the inverse square law for the electric force between two charges. Okay, so in short, Charles Coulomb measured the magnitudes of electric forces between charged objects using the torsion balance which he invented. Okay, the operating principle of the torsion balance is the same as that of the apparatus used by Cavendish to measure the gravitational constant, with the electrically neutral spheres replaced by charged ones. Okay, so in short, Coulomb's law states that Fe is equal to Ke Q1 Q2 of R squared, where Ke is called the Coulomb's constant. Okay, and the value of the Coulomb's constant is Ke is equal to 8.9876 times 10 to the power 9 Newton square meter per Coulomb squared. Okay, so given two charges and the distance between them r, between their centers, you can calculate Fe, which is the force that is between them. I'm sure you remember from your studies of physics. We can quickly jump to another section. Newton's law of gravitation, Fg is equal to gmemp over r squared, or F is equal to gmm over r squared. Okay, both of these are inverse square laws. Okay, but the Newton's law of gravitation is used to calculate the force between two bodies. Okay, not two charged bodies, two bodies. Okay, separated by a distance of r between them. from center to center. Okay, so this is a gentleman. He was a French physicist who devised Coulomb's law. Okay, his major contributions in science were electrostatics and magnetism. During his lifetime, he also investigated the strength of materials and determined the forces that affect objects on beams, thereby contributing to the field of structural mechanics. In the field of economics, his research provided a fundamental understanding of the ways in which people and animals can best do work. Okay, thank you, Mr. Coulomb. So we're talking about the Coulomb's constant, okay, which can also be written in the form of Ke is equal to 1 over 4 pi epsilon naught, where epsilon naught is known as the permittivity of free space, and as the value of E naught is equal to 8.8542 times 10 to the power minus 12 Coulomb squared per Newton per meter squared. Okay, and we know that the smallest unit of charge E, okay, known in nature is the charge on an electron, 1.602 times 10 to the power minus 19 coulombs. Okay, we can use that to calculate the charge, okay, between any two protons or any two neutrons. Okay, so here is a short table showing you the mass and the charge of an electron and a proton respectively. Okay, and you can use that to calculate the following example. You can just pause the video, okay, and calculate the following example. The electron and proton of a hydrogen atom are separated by a distance of approximately 5.3 times 10 to the power minus 11 meters. Find the magnitudes of the electric force and the gravitational force between the two particles. Okay, so you can pause this video, and using the data in the previous page, okay, you can use this data in the formula that I gave you earlier for force between two charged particles and force between two bodies to approach that question. So you can pause the video and let's give ourselves a minute to work it out. Okay, after working it out, this is the solution to the question, and these are the formulae that you use. Think about the two particles separated by the very small distance given in the problem statement. Okay, now already we've said the force between them when you talk about their masses is gmm of r squared. When you talk about the charges, is F is equal to KEE over r squared, where K is Coulomb's law, Coulomb's constant. Okay, so using Coulomb's constant to find the magnitude of the electric force, we know that K is that, and we know that the charge on a proton and the charge on an electron is the same, okay, which is 1.6 times 10 to the power minus 19, hence the square. Then we divide by the distance between them. The answer you get for the electrostatic force or electric force between them is 8.2 times 10 to the power minus 8 Newton. Okay, and then using Newton's law of universal gravitation, right, in the table to find the magnitude of the gravitational force, we know that G is equal to 6.67 times 10 to the power minus 11 Newton square meter per kilogram squared. We know that the mass of an electron is that 9.11 times 10 to the power minus 31 kilograms. We know that the mass of a proton is 1.6 times 10 to the power minus 27 kilograms. And we divide by the distance between their centers, which is 5.3 times 10 to the power minus 11. answer we get is 3.6 times 10 to the power minus 47 newtons. Okay, so from this we can see that the electrostatic force is very greater than the gravitational force between the two particles. Okay, so I hope that you enjoyed our short tutorial on introduction to electrostatics, Coulomb's law and Newton's law. Okay, if you need more lessons, in-depth tutorials on Newton's and Coulomb's law, and if you want to know how to do the resolution of forces between two particles, okay, you can hit me up and you can contact the Maths Tutor online and we can get to business. Thanks for watching this video, and I hope that you enjoy your studies and succeed in your June advanced level examinations and your November advanced level examinations, or any physics exams, mathematics exams that you're going to be doing. Cheers!